This interview was recorded on February 9th, 2021. Hi, I'm Len Epp from LeanPub, and in this episode of the Front Matter podcast, I'll be interviewing Andy Grove. Based in Broomfield, Colorado, Andy is a software engineer who specializes in work on query engines and distributed systems, who currently works as principal distributed systems engineer for NVIDIA. You can follow him on Twitter at AndyGrove73 and check out his website at andygrove.io. Andy is the author of the LeanPub book, How Query Engines Work, an introductory guide. In the book, he introduces readers to the topic of query engines generally and shows you how to build a working SQL query engine. In this interview, we're going to talk about Andy's background and career, professional interests, his book, and at the end, we'll talk a little bit about his experience writing a book as a self-published author. So thank you very much, Andy, for being on the Front Matter podcast.
Thank you for having me.
I always like to start these interviews by asking people for their origin story. So I was wondering if you could talk a little bit about where you grew up and how you first became interested in computers and technology.
Absolutely. So I grew up in a small village in England, not too far from London. And around the age of 11 or 12, my parents decided to send me on a kind of a course over the summer. It's just like a 2 or 3 day thing at my local library where they were teaching computer programming. I had no exposure to computers before this time. And after 3 days doing this, I was kind of hooked. And pretty soon I decided that's what I was going to do with my life. I was going to be a programmer, as we called it back then. So yeah, that's where it started. And I had intentions to go to college, but I ended up leaving school at 16, which is when high school actually finishes in England, and went straight into a career as a junior programmer and kind of worked my way up from there. And that was a very long time ago, about 30 years ago.
So that's really fascinating. So your first programming job was when you were 16 or 17?
Yeah, I was 16 when I started that job. I was incredibly young, commuting into London every day. And I was learning so much. I was, really enjoying it. Barely earning any money, of course, but it felt good to be doing what I was passionate about and getting paid to do it.
And what was your first job?
So I worked for a finance company, and I helped build litigation systems. So there's some reporting. It's basically database work using some really old technology called DBase, which was a language. So it allowed you to process data in files. This is IBM XT computers way before client server or distributed systems. The company was mostly mainframe based, and PCs were kind of a new thing they were experimenting with.
Yeah, just to set the timeline here, I'm just looking at your LinkedIn profile here. But yeah, your first job then was in 1989.
Right.
So you were there at a period of time that would be kind of unrecognizable to a 17-year-old getting into software engineering now.
Yeah, absolutely. It's kind of crazy looking back. I remember being really excited when this thing called the internet kind of was invented and the World Wide Web. It was suddenly much easier to learn new skills. I no longer had to, get into my local town and find a bookshop. So,
I was just going to ask, what was it like learning? I mean, you were obviously learning on the job, and so you would buy books. Did they have a corporate library or anything like that?
No, this company was it was a pretty small company, and yeah, it was very hard to learn. The only ways to really learn at the time is mostly through working with other people that had more experience, which was frankly everybody else at the time. So that's good. And yeah, going to the library or going to a bookstore.
And did you find it exhilarating or intimidating to commute into London every day as such a young person?
Yeah, I mean, a bit of each. More boring after a while, of course. And being England, the weather isn't the best, so it's kind of a drag standing on. I have those memories of standing on a train platform in the freezing cold and rain in the mornings. And that's one of it's kind of going off topic, but I had the opportunity later on in my career to start working in the US. I had some trips out here, and I noticed that everybody tended to kind of drive to work more. There was less train commuting, and I wonder if that was one of the things that kind of made me kind of want to move out here. I think it's maybe a factor.
Yeah. I'm looking forward to actually asking you about that move in a bit. But yeah, just longtime listeners of the show know that I spent some years living in London myself, and
Okay.
I still remember commuting. Usually I was on the tube, and particularly on the Northern Line. And I remember a couple of interesting things about it. One about how much it sucked. I mean, it really sucked. Like sometimes you 2 or 3 trains would go by before there'd finally be, 1 or 2 people might squeeze out and you squeeze in. And it's sort of hard to imagine already in COVID times, but you were physically pressed up against many different people. And one of the curious things about commuting in London. I don't know if it's like this now, but at the time in the late 90s, you could be on a platform with like 500 people and it was dead quiet because no one would talk. And the only time people would talk would be, if you were on this crammed train and the announcer started saying something and no one could hear, and then everybody would laugh. But other than that, it was dead quiet. It was just a curious feature of commuting in London. But yeah, a very unpleasant experience, whether you're on the train or on the tube. And I can see how driving would be very attractive as an alternative. So yeah, so you did eventually move to the US. What was that? I've actually spoken to quite a few people who've moved from one country to another on the podcast. What was your experience like? Was it easy? Was it hard?
It was, a bit of each. So, I obviously speak the English language, so that made it very easy. I know some people moved here, they have to learn the language, and that's definitely a challenge. So from that point of view, it's fairly easy. I came over to work for a very small company, a startup. It wasn't a corporate. So I didn't have the kind of relocation package. So that made things kind of challenging on the financial front. But I knew that I would have, or at least I had a strong belief that I would have better career opportunities over here. There are lots of software jobs in London and the UK, but the software industry itself, as you know, is mostly kind of US based. So I kind of took the risk that there'd be some short-term pain, but there'd be kind of longer-term benefits from moving here.
And did you move to the Denver area?
Yeah, so I moved straight to Broomfield, Colorado, and the guy that I was going to be working with is based here. My wife and I were checking out the local school districts, and we found the Boulder School District seemed to be good, and Broomfield's part of the Boulder School District. So those were really the main reasons. It's very hard to choose an area to live in another country that you have no experience with, and we had to pick somewhere. We chose Broomfield. We're still in Broomfield, so I guess that worked out well.
Was there any culture shock?
Yes, there was. The things that are really a big contrast coming from England, they're pretty obvious ones. Healthcare system, guns. Those are really the main two that are kind of shocking to us, the differences. And in those early years, we, again, not working for a corporate, we didn't have amazing health insurance. And we had some surprises there for sure.
Yeah, I've heard that before from people, the sort of shock of going, either way, like from the States to a place with public health care, or right, from a place with public health to the United States. And I think the one of the best descriptions or most evocative descriptions I heard about it was from an American professor, a professor at a Canadian university who was moved there from the United States, who said, there's an edge to life in the States that I don't sense here in Canada. And she said, I think it's probably partly down to the healthcare thing. And she was speaking specifically about her students, right? They didn't seem to have this kind of sense of a cliff they might fall off if they don't get everything just right.
Wow, that's interesting.
Yeah. And so one question I actually always like to ask people if they're in sort of, IT is, and it depends, the formulation of the question depends on how it went for them. So, but if you were starting out now with the intention of having a similar career to the one that you've had, would you choose to study formally at computer science at a university, or would you choose another path?
That's a great question, and I would. So I have fairly grown-up children, and my eldest son is actually now studying a computer science degree, which I strongly encourage him to do. I was self-taught, and I've learned a lot from working with some great people over the years. But I feel that if I had had the opportunity to go to college, I would have taken it. I think there is a benefit to learning more of the theory early on, for sure.
Okay. Thanks very much for that very clear and straightforward answer. Sometimes it's a little bit more convoluted, but that's great. Just before we go on to talking about your book, I wanted to take an opportunity to do a little segment that we introduced way back in March, where we ask people, the guest, how the pandemic has been affecting them. So it's been quite a few months now, but if you could talk a little bit generally about what it's been like in the area where you live in Broomfield, and how or whether the pandemic has affected your professional activity.
Sure, absolutely. So Broomfield, COVID's, pretty bad here. More recently, the numbers are going down. But from the start, my family, we decided to be pretty cautious about the whole thing. So, initially we were just doing the essential trips, groceries and so on. But the interesting thing was I actually started my role at NVIDIA back in March. So I had two trips for out to one of the offices actually in Champaign, Illinois. I went out initially, I think it was February, for an interview, and then went back a few weeks later for my first week in the role. And the initial plan was that I would be doing more of these trips to spend more time with the team. But this is just as the world was realizing the kind of seriousness of the COVID situation. So I ended up not doing that. So that was definitely a challenge, starting a new role with a new team and being fully remote. I would have preferred to have more time with the team early on to kind of get up to speed. So that was a challenge for sure. But I'm used to working from home. I've actually worked mostly from home for the last, gosh, I want to say 15 years now. So that side of it was quite easy for me, quite familiar. I have a good home setup, good espresso machine, which is really important. So that part wasn't so bad.
And did people start wearing masks very soon in your neighborhood?
Not really, no. In fact, I remember my wife and I, we were at Whole Foods one time, and we were pretty much the only people wearing masks. We decided early on that it might be a good idea. And I remember the staff kind of suppressing their laughter, serving us. And of course, 4 weeks later, they were wearing masks too. So, yeah, I mean, it doesn't hurt to be cautious in these situations when there's a lot of, there were a lot of unknowns at the time about how the virus was being transmitted. So, we have children, we played it safe.
Oh, that's great to hear. Thank you for sharing that. One thing I've noticed, and this is just sort of anecdotal, but that people who work in the kind of tech industry seem to be a little bit, early adopters of anti-COVID measures. It certainly became a reality for me long before it did for many of my friends and family and things like that. Specifically here where I live on Vancouver Island, in the city of Victoria. And it's only in the last couple of months that people have actually started regularly wearing masks outside. I would say it's about half. I don't actually. If the convention turned into, hey, yo goober, put on a mask, I'd do it in a heartbeat. And it looks like it might finally be getting there. But I know that in some places like, New York City and stuff like that, it was like we wear a mask like outside all the time from the beginning. All right. So just moving on. Oh, yes. Yeah. Just before we go on to talk about actually talk about your book. So NVIDIA sounds like a pretty exciting company to work for. What's your role there generally at a high level?
Sure. So basically, so there's a project called Apache Spark, which is an open source project it's a query engine distributed system. And NVIDIA, as you know, make GPUs, which are these really cool chips that, makes things run faster and really good at running things in parallel. And the project I work on, we make Apache Spark run on NVIDIA GPUs. So at a very high level, that's basically the role. And, obviously the subject matter there is very similar to my book. And it was through working on open source projects around query engines that essentially helped me get the job at NVIDIA because I had the relevant experience.
Okay, thanks very much.
Sure.
I'm sure we'll get maybe into a little bit more of the details of that when we talk about your book. But so you've published this book, How Query Engines Work, an Introductory Guide. And I thought maybe the best place to begin would be where you begin in the book, which is what's a query engine?
Yeah, so a query engine is basically a tool that lets you run queries against your data. So basically asking questions to get value from your data. So it could be running an SQL statement against your files that you have. You could be running these queries just within the process on your laptop. Or if you have lots of data, terabytes of data, you'd want to be able to run this query across a cluster of servers so that you can process the data in parallel and complete the query more quickly.
Yeah, and so to sort of put into like a kind of like, from a non-technical perspective, and I'm a non-technical person. I mean, I've done some programming and I've interviewed, 150, people who are very technical for this podcast so far, so I know a little bit. But basically, there's some information stored somewhere on a disk or on many disks, and you've got to have a way of that, and that information is structured in a certain way, and someone has to make a decision about how it's structured. But then, if you want to go ask it a question, like how many books have I sold in the last year or something like that, right? You've got to have some software that knows how to ask that particular structure that you've chosen, particular questions, and get the right answer back.
Absolutely. And, many people will be familiar with traditional SQL databases. And the way they operate, they provide a very structured way of dealing with data. So typically the first job is to get your data into the database system, so importing your data somehow, and then you can run queries within the database. So databases contain a query engine. They also have a storage engine and transactions and all these things. I guess my area of expertise more is kind of modern query engines where you don't have to import the data first. Your data is just where your data is, and you want to run queries against that data without having to import it first. So a query engine basically translates the question you're asking, the query. It translates it into this query plan with like all the different steps that the query has to do. And at the very bottom of this plan is accessing the data in some file somewhere. So maybe it's a CSV file, maybe it's a Parquet file. Some of these files are structured and have schemas built in, some don't. So if it's a CSV file, for example, CSV files are just strings separated by commas. So often with a CSV file, a user would want to tell the query engine, hey, here's the schema for this file. Column 2 is a decimal type, column 3 is a string, and so on.
And there's a difference between columnar data and row. I don't know actually have the language for it, but I mean, if you go into a little bit about that.
Sure. So let's just go back to a CSV file, something that most people are familiar with. So or a spreadsheet. So it's tabular data, and there are rows and there are columns. You can look at it either way. And historically, many query engines have been row-based. So, processing one row at a time is a very natural way to think about data. So if you're processing, so LeanPub, you have books and authors, and sales. So if you want to you want to see how many sales there are by author, you just go through the sales one by one and process it that way. And that's fine. But columnar data has certain advantages. Basically, if you read data a column at a time and process it a column at a time, let's take a really simple example. You're looking at all the sales for a particular book. You want to know the total. If you're processing it as columnar data, you can read the column of all the sales amounts into memory. So all these numbers are next to each other in memory. So just walking over them is very efficient because they're contiguous. And if you want to just sum those numbers together, you can take advantage of a feature on CPUs called SIMD, SIMD, which stands for Simultaneous Instruction Multiple Data. Very fancy term, but basically it means you can give the CPU one instruction and it can add up multiple numbers at the same time rather than doing one at a time. So you get a good performance improvement from doing that. And that's a concept. It's a concept known as vectorized processing. And if you go from CPU to GPU, this is what GPUs are. GPUs, you load a ton of data on, and it can run code against that data with a very high level of parallelism. Like modern GPUs have thousands of cores. So once your data's on the GPU, you can process that data very quickly. So that's really why people now are moving more to columnar data for these, to take advantage of modern hardware.
And I think you write in the book about that there are limitations of structured query languages like or SQL when it comes to so-called big data. And I was wondering if you could talk a little bit about how it is that a structured query language can have limitations when it's dealing with like tons and tons of information.
Sure. So I guess there's a couple of different ways of looking at limitations of SQL. I mean, SQL is I think the most widespread query language that many people will be familiar with. And it's really great for certain queries, but I guess there are two real limitations. One, in the language itself, there are times when really you need to have you need to write custom code to do some particular operation that you need that isn't part of the SQL standard. And SQL does allow you to define like user-defined functions. So it does support that to some degree, but sometimes you really need to take control as a developer. And there just may be things you can do more efficiently that you can't do in SQL. So that's one kind of category of limitation. But I think the more interesting parts of the question is the big data part. So SQL is very flexible, and you can take data from different files and join them together in different ways to build these really complex queries. And once your data is distributed across lots of servers on a network, You have to be really careful about how you run that query because data is going to need to move around between servers to fulfill certain parts of that query. And this is where there can be a ton of overhead in distributed systems, depending on the type of operation that you're performing. And this is really where this kind of modern age of distributed query engines comes in. They need to figure out how to optimize the query in such a way as to kind of minimize data movement, do as much processing in parallel on each computer before the results get to the next stage in the query and so on.
And I'm going to put this very naively, but and what you're actually trying to do really matters for how you decide to set things up and make things work. So for example, if I'm a self-driving car and I'm asking questions about the data that I'm receiving in real time from my LiDAR or something like that, how I structure the storage of that information as it's coming in and how I design the way I'm going to be asking it questions. Like, is that a person on a bike or is that a hedge? That's going to matter a lot for how I set up my system.
Yeah, absolutely. And one important thing with query engines is how you partition your data. So taking a naive example, you want to get the total number of sales of books per country. If you happen to organize your data where each country is its own set of files, then it makes that query kind of efficient because you can just run the same query in parallel across all these data sets that are already organized by country and then just combine your results. If your data isn't partitioned that way, you've got to ask all these servers to do the same query and they're all going to produce some sums for all the countries. Then you have to take those results, put them together, and then run another query on those to get the final sum for each country. So that's kind of a good example of how organizing the data in a certain way can make the queries more efficient.
And is this related to what a type system is? I was wondering if you could talk a little bit. You talk about these in your book, and what is a type system? And
sure. So not really. So a type system is really representing the different data types that you're dealing with. So we have text data, we have numeric data. You can have structured data, which is where you have concept of maybe like an object that has different attributes. So maybe a car is the structured type, and it has attributes like engine size, horsepower, and so on. And when you're querying data, obviously you potentially you're querying all these different file formats. So we're talking about CSV and Parquet. They have CSV is strings, but Parquet has its own data types. It has its own type system, and the SQL language has its own types as well. And when you're building query engines, this is a big concern because you're very often conversing between these different types, and that can get kind of complex. So if you're querying a CSV file and a Parquet file in the same query, you've got these type conversions going on. And really, it's good to pick, when you're building a query engine, you typically have to pick one type system to be the one the query engine actually understands. And then you have to convert all of the inputs into that type system. And in the book, I talk about Apache Arrow. So I'm, heavily involved in the Apache Arrow project, and the query engines that I've been building are using Apache Arrow as the type system, and it's a columnar memory format, basically.
And can you talk a little bit about the Ballista project? I hope I'm pronouncing that correctly.
Yeah, absolutely. So this is there's a bit of background to this. It's kind of a long and windy story, but so I started out at the start of 2018. I decided to start building a query engine in the Rust programming language, and I called it Data Fusion. And very early on in that journey, I decided to make it columnar, and I was looking for a type system, and somebody pointed me towards the Apache Arrow project. And after I studied Apache Arrow, and it seemed like a really good fit, but there wasn't a Rust implementation available. At the time, Apache Arrow has implementations in many programming languages, but Rust wasn't one of them at the time. So I ended up building my own kind of version of Apache Arrow in Rust. And later on, I donated that to the Apache Software Foundation. So that became the starting point of the Rust implementation of Arrow. And it's come along a long way since then. There's a community behind it. So I just kind of got the ball rolling there. So with that in place, I was able to then make more progress with Data Fusion. And
Data Fusion, that was it, yeah.
So I got that to a point. So basically, Data Fusion is a query engine that supports SQL. It's implemented in Rust and uses the Apache Arrow memory model. And once I got that to a certain point, I also was able to donate that to the Arrow project. So that's actually part of Arrow now. And so there are two kind of building blocks in place now. There's the Arrow type system in Rust. There's this Data Fusion query engine in Rust. And that allowed me to move on to Ballista, which was always the kind of the long-term goal of building a distributed query engine. So with Ballista, I'm trying to take the work that's being done with Data Fusion, which runs on a single computer, and make it run distributed on many computers, basically.
And what's the advantage of running a query engine on distributed computers?
So basically, if you have more data, so people talk about this concept of big data, which is a very vague term. My definition, I didn't invent this definition, but the definition I've seen that I like the most, big data means there's more memory than you can fit into memory on your computer. So if you have a laptop with maybe 32 gig of RAM, big data is anything over that. If you have like terabytes or petabytes of data, you can't even fit it on the disk on your laptop. So this is where you need a cluster of computers to be able to process that data.
Great. And what was the inspiration for writing the book? Were people asking you, can you write an introductory guide or step us through the process of building one of these?
There are a couple of factors. So I had to go through this journey. I had to teach myself how to build a query system, a query engine, by building a query engine and kind of just figuring out stuff as I went along. It's kind of a painful journey. And I looked at some open source query engines and I found that the documentation was pretty sparse. It seemed to be that the people building the project would have deep understanding, and you'd have to work with these people for a period of time to kind of learn how they designed it, what the design philosophies were. And I just thought it'd be really good. While I had that knowledge, I just really wanted to get it down for other people to learn from. And I was also looking to build a strong community around Apache Arrow and Data Fusion. And I figured what better way. So I kind of designed Data Fusion with a certain design philosophy. So I figured, why not write a book explaining from start to finish my approach for building a query engine. And then that allows people it makes it much easier for people to get up to speed with the overall design, and makes it easier for people to contribute to the project.
And just moving on to the final part of the interview, we were talking about the actual practical experience of writing and publishing a book. Can you talk a little bit about why you decided to choose LeanPub as your publishing platform out of all the other platforms out there?
Sure. So it was actually, I guess, kind of a random event. I was talking to a guy called Matthew Powers, who has written the LeanPub book. I forget the actual title, but I think it's something like Writing Beautiful Apache Spark Code.
Yeah.
And I was chatting with him. He told me about LeanPub. He was very excited to share it with me. And I was really impressed. And I decided to give it a go. I hadn't considered writing a book before. I would have been very worried about just learning about using different tools or the process of writing a book. But I could see that with LeanPub, I was very used to writing Markdown files already for documentation, and I could see how simple the process was of turning these Markdown files into a book and pushing it out to a platform where people could buy it. It kind of seemed too good to be true in a way.
I apologize for not knowing the answer to this next question already, but did you publish the book in progress or did you publish it all in one big chunk?
I did publish it in progress, and
okay.
That was one of the really attractive things for me about the platform. I mean, as a software developer, like everything I work on is always in progress. There's no such thing as a finished software product. And I really liked that approach to the book, that I could publish sections early and get feedback from people, which would help me improve the book. So that was really great. And I would say, so although the book is complete in some sense of the word, all the chapters are there and there is content, and there's a start and a finish and there's a good flow. But I definitely intend to improve the book and add more content over time, because I'm still on this journey of learning about query engines, and there are sections that I'm learning about right now, and I'm looking forward to expanding those sections in the book.
And how did you get feedback from people as you were publishing, or how are you currently getting feedback from people? And one thing for people listening, we at LeanPub, we very much encourage authors to interact with readers to help them improve their books, or decide what to write next, or decide what to stop writing or what not to write, things like that.
Yeah, absolutely. So fairly early on, I was actually asking people on Twitter, I was asking people, what did they want to hear about in the book, whether particular things they wanted me to write about. I also encouraged people to give me feedback over Twitter or through the LeanPub forums. And that's been really great. I have had some really good feedback.
Oh, so you've been using the forums?
Yes.
Yeah, just to explain this so to anyone listening, after you publish a LeanPub book, you have an option to create a forum online. We use the platform Discourse, then lets people ask questions about the book or provide feedback, and so that people have been using that. That's great.
Yeah, they have.
Okay, that's fantastic. The forum I spend most time on is our authors forum, and answering authors questions, which we have for people as well. All right. Well, I guess the last question I always like to ask the guest on the podcast, if they're a LeanPub author, is if there was one thing we could build for you, or one thing you really hate about LeanPub that we could fix for you, what would you ask us to do?
Wow, that's a tough question. I haven't really run into any issues. It's a simple platform to use. I guess maybe one thing, this may be an area that I just don't know what the capabilities of the platform are. But I wonder how easy it is for people to, like, if I wanted to sell the book through, like, if people have Kindles and they wanted to buy the book and read it on the Kindle, I don't know if that's something they can do easily today with the platform.
Yeah, that's a great question. Thank you for asking that. So specifically, so when you use LeanPub to write a book, and whenever you click the button to preview or publish, we create it in PDF, EPUB, and Mobi. And we absolutely encourage people to distribute their books as widely as possible. I mean, in our ideal world, all the eyeballs would be on LeanPub, but they're not. And so if you want to sell your book to people, you can just take that Mobi file and you can sell it on Amazon if you want. You can take that EPUB file and you can sell it on Apple, on their books platform. Very much encourage that. In fact, it's not a requirement if you write a book on LeanPub that you actually publish it on LeanPub at all. Some people don't do that. They write their book and then they create the previews that no one can see, just you. And then you take that file and you go onto the service that you actually want to use. And that's perfectly fine. And we also actually have a pretty popular feature, which is our print-ready PDF output, which basically means that when your book is done, and of course it's never really done, right? But when it's close enough that you want to commit to print, you can actually just click a button. I mean, you adjust some settings and stuff, but in the end, you just click a button and we give you the PDF file that you need to upload to services like Amazon or Lulu or something like that, or Ingram, so that people can get print on demand copies of your book as well. So we absolutely encourage people to use different platforms, and we try to provide them with everything that they need in order to do that.
That's very cool. I didn't actually know all of that, so I've learned something new there. That's great.
That's great. Well, that's our fault for not communicating better about it. Well, Andy, thank you very much for taking the time to have this great conversation today, and thank you very much for being a LeanPub author.
Yep, thank you for having me. That's been a pleasure. Thanks.
And as always, thanks to all of you for listening to this episode of the Front Matter Podcast. If you like what you heard, please rate and review it wherever you found it. And if you'd like to be a LeanPub author yourself, please check out our website at leanpub.com. Thanks.